Will the history of astronomy be divided between before Webb and after Webb?
Yes, I believe it will be.
So something real is happening, but we can't tell yet if it's a mistake in our observations, a mistake in our interpretation, or just something nature is surprising us with, such as a new kind of dark matter, a new kind of dark energy, or something else that would be really exciting to discover. So if there's a Nobel Prize in here, that could be one of them.
Look at this image. What you see here is a very distant cosmic structure shining brightly in the early universe. But the discovery of this bright object has solved a long-standing mystery of astronomy, because our current understanding of the universe says that our universe came into existence about 14 billion years ago. And after the Big Bang, the universe went through a period of complete darkness called the Dark Ages. This was the time when the universe was filled with clouds of gas everywhere. Even if we built the most powerful telescope ever built, we wouldn't be able to see beyond the Dark Ages. But for decades, scientists have been noticing that some strange light was coming from dark clouds. A serious discovery has sparked debate among astronomers. Recently, for the first time, the Webb telescope observed two ancient galaxies. Intriguingly, these galaxies seem distinct from those familiar to us, prompting questions about their origin within our universe. Such discoveries of Webb telescope have raised some big questions. Are we wrong about the age of our universe? Or are we wrong about the origin of these galaxies? So what are these strange lights? And where are they coming from? Well, new discoveries from the Webb telescope have finally revealed this mystery and conclude that what we previously thought about the early universe may need to be revised. This new Webb telescope image revealed that this light is actually a rich source of Lyman alpha emission. This image shows that there were more galactic merges in the early universe than we could see before. The Webb telescope got going. Those merges and interactions and the abundant star formation that they spawned are responsible for both creating the Lyman alpha emissions. But scientists previously believed that these emissions should have been blocked by the dense hydrogen clouds that filled the space between galaxies during the Dark Ages, and WES could not have seen these emissions. But we are seeing it. Well, researchers recently revealed that as stellar mass gathered and stars formed in these early galaxies, two things happened. The stars emitted Lyman alpha emissions, and they created bubbles and channels of ionized hydrogen in the light-blocking neutral hydrogen gas. The bubbles and channels allowed Lyman alpha emissions through, so this shows that the stars could detect objects beyond the Dark Ages. And surprisingly, in another recent deep field image, scientists found two galaxies that existed beyond the darkness of the early universe. And scientists are now saying that these galaxies are not like the ones we have seen. On the other hand, both of these galaxies are highly red, shifted, and astronomers claim that this would be a serious problem if these objects are, indeed, galaxies. This graph representation provides a comprehensive overview of distant galaxies as seen through their remarkable capabilities of the Webb telescope. Here we can see the farthest galaxies confirmed through spectroscopic OB observations. One of them, named GNZ 11, lies approximately 13.2 billion light-years away, and was initially spotted by the Hubble telescope. A recent image from the Webb telescope has revealed something extraordinary in this galaxy. Astronomers have identified a supermassive black hole at its center. This finding establishes it as the most distant black hole on record, forming just 400 million years after the Big Bang, challenging our understanding of black hole formation due to its enormous size. Scientists are saying that the size of this supermassive black hole does not fit with the time period of the universe, because the death of the first stars, or the merger of black holes in the early universe, cannot create such a large black hole. We need a completely new way of thinking about the formation of these massive black holes so early in the universe. But there is something else in this data that has shocked astronomers around the world. Well, as we can see, these galaxies are the most distant galaxies discovered by the Webb telescope, and the red signs indicate that these galaxies have already been confirmed from spectroscopic observations. So the most distant confirmed galaxy right now is named GZ 130, which existed about 13.47% billion light-years away. There is something more to this data here. we can see the two most distant galaxies located at a redshift of around 16. This means that these galaxies existed beyond the Dark Ages. This is surprising because our standard cosmological models say that galaxies first formed at the end of the Dark Ages. But here we can see massive and strange galaxies that existed beyond the Dark Ages. This discovery shows that galaxies were formed much earlier than our theories had predicted. The problem now is, how do we explain the existence of these galaxies? One way we might think is that our universe may be much older than we thought, or that there is a possibility that something strange may have happened after the Big Bang that accelerated the formation of early galaxies. Well, spectroscopic observations of both these galaxies are yet to be made. But if spectroscopic observations confirm their predicted red shifts, the basic foundations of cosmology will be shattered. Well, there is another hypothesis which have recently become popular among scientists, which we know as the conformal cyclic cosmology. This cyclic universe model may explain the existence of these strange early galaxies. Nobel laureate Dr. Roger Penrose says that there was a universe before us, which he refers to as the previous eon, and that black holes evaporate at the end of the previous eons, predicted by Stephen Hawking, and the evaporated energy from that black hole gives birth to the Big Bang of the next eon. He also postulates that dead black holes from the past universe accelerated the expansion of our early universe. Scientists believe that these dead black holes from the past universe may explain the existence of supermassive black holes and huge early galaxies in the early universe. Well, everything the Webb telescope has discovered so far poses a challenge to our understanding of the universe. It's no surprise that even in just its first 3 years of science operations, the JWST has broken a slew of cosmic records, including records for most distant galaxy, most distant protocluster of galaxies, most distant black hole, most distant red, supergiant star, most distant gravitational lens, and most distant quasar. These findings suggest the possibility that our universe might be much older than initially believed. Alternatively, it could be part of a chain of interconnected universes, or it might have always existed without a definite starting point considering the apparent infinite size of our universe. The idea of its age being infinite becomes plausible. The conventional concept of the Big Bang may just be a specific moment in the ongoing evolution of this perpetually existing causal cetera, rather than a true beginning. Finally, if you guys have finished this video, don't forget to comment what you think about these discoveries and what you think about the age of our universe.